Well, hello. Today, we're going to do a quick review of the distribution of data, and then we're going to talk about measures of center. First, let's talk about the distribution. We have skewed right, where most of our data is to the left. We have skewed left, where most of our data is to the right. And then we have really the most common type of curve, which is our symmetric distribution. And this is really going to be our life for the next month. In fact, there's a special statistics term for this curve. Maybe some of you know it. This is called the normal distribution. In this case, the average is right down the middle, and you've got a little bit on either side, okay? And this describes many, many variables in life. For example, if you walk down the street in your city, most of the people are going to have a height right in a certain range, probably 5'4" to 5'11". You're going to have a few tall people and a few less tall people, but most everybody's kind of in the middle. IQ is often described as normally distributed. A few up here, a few go to Avon Old Farms, and everybody's right in the middle, okay? Normal distribution. Think about it, right? Grades. Most kids are stuck right in the middle. You get a few up and a few down, right? Think about your athletic events. Cardio, when you go to your soccer practices, you have a whole lot of kids are about the same, and then there's one or two that are really good, and the coach's kid, right? So things are normally distributed, right? In the orchestra, there's a whole lot of kids, right, that are sitting there playing the same instruments or playing the same level of ability. Then you've got the first violin, and you have the conductor's kit at the other end. So normal distribution, this is really what we're going to talk about for the next month. And we're dealing with the symmetric data here today. What we're going to do now is we're going to look at a set of data and describe how specifically we deal with summarizing. Let's take a look. Here is the 2016 U.S. Women's National Team goals scored per game. Okay, so we're going to take 20 games, and these are the goals that were scored in those games. Right now, it's just a list of numbers. That's nice. We can see that maybe it's a small enough list so we can see, oh, there's a 10 and a bunch of ones. But what else can we do with this set of data? Funny you should ask. These are some of the main descriptive statistics that we are going to work with. Many of them you already know. But let's just go through each of them using this set of data as our example. Let's start. The mean. Now, as we've said before, the mean is something you've been calculating most of your life, okay? It's the average. So let's write that down. The mean is the average. What do? You take the sum of all of your items from n equals 1 to n of a sub n, and then you divide it by n. Okay? That's your mean. And you can see that in your notes. This is a shorthand mathematical notation. Anytime you see a big sigma, that means sum. So if I'm going to take the average score here of the women's national team, I'm going to take 5 plus 5 plus ... all the way up to 3 and divide that by 20. Okay, pretty straightforward. And I should get 2.44. You can always check this on your own. Pause the video and add those up. See if you can get 2.44 goals. That's the average. It is a way to describe the center. Okay. What about the median? Then let's just go through each of these. Now, in a subsequent class, we'll talk about how they're related, when the mean is better descriptor than the median, how to get the mean and the median, if your data is skewed right, skewed left. For now, let's just define the terms, okay? So we're going to get all these terms defined, then we'll give our P-brain a few days to think about it. Median. You might know this as well. The middle number. Okay? If your data set is odd, then you simply take the middle. And if your data set is even, we take the average of the two. So this is an even set of data. So watch what I'm going to do. I'm going to list them in order. Now I'm going to show you a little trick to make sure you get all of the numbers listed. All right, we're going to cross them off in red as we list them. So let's go ahead and do that now. 1, 1, 1, 1, 1, 1. There are 6 ones. 2, 2, 2, 2, 2. I've got 5 2s. 1, 2, 3, 3 3s. 1, 4. Is that right? And then 1, 2, 3 5s, a 9, and a 10. Okay, can everybody see that? I kind of made these ones a little bit too far apart. I had to squeeze the other ones in. So now I've got 20 data points. And I'm going to go to the middle. Now it's an even set of data. So the middle is going to be numbers 10 and 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Now why is that the middle? Because there's 9 on either side, I hope. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a 10, not a 1 and a 0. Okay, so I've got 9. I take the average of 2 and 2. On my planet, the average of 2 and 2 is 2. So now we go over here, and here's my median, 2. So in this case, you can see the median is a little less than the average. I want you to think for a second. You can even pause the video if you'd like. For this set of data, why would the average be greater than the median? Let's pause. Don't say it out loud. Let's just think for a moment. You can pause the video, and see if you can come up with the answer. Okay, the answer is because look at those numbers to the right. I have a 9 and a 10. What will those two values do to the average? That's right, they're going to pull it up. We have a cluster of numbers here. So you could say this might be a little skewed right. We have a cluster of numbers here. That 9 and 10 are going to pull the average up away from the median, which is 2. Okay, standard deviation. Again, we're going to talk about this in detail in future classes, but standard deviation is basically a way to measure the distance of each point from the mean. Distance from mean. Think about it. And you know this from classes, right? If I've got a class with, 12 kids and they take a geometry quiz, I could have an average of 80, but I could have some kids getting 60s and some kids getting hundreds. Whereas another class would have an average of 80, but some kids getting 75s and some kids getting 85s, right? The standard deviation would be a way to differentiate those two classes. Standard deviation, distance from mean. Here you go. We're going to take the sum of each data point minus the mean, A bar. So there you go. There's a little notation for you. X bar, A bar, P bar, N bar, that means mean. So if you see this ever written, X bar, that's average.
So it's just the sum minus the mean.
Yep. We add all those up, but unlike the average, so the average we divided by n, this one we're going to divide by n minus 1. And I can explain that, but really not until chapter 7. Okay? And then when we're done with it all, we're going to take the square root. Now again, you just need to know that for now, but let's call this a sub k, from k equals 1 to n. And the same here, a sub k from k equals 1 to n.
Wait, so it's the sum of each data point minus.
So let me explain to you what this is going to do. So we want to know how far we are. So we're going to take 5 minus 2.44, 2.56, square it, plus 5 minus 2.44 squared, plus 10 minus 2.44 squared, plus 5 minus 2.44 squared, plus 2 minus 2.44 squared, negative, but we square it, plus 1 minus 2.44. You see what I'm doing here? Then we add all those up, divide by n minus 1, and take the square root. And if you think about it, right, that's going to be very similar to the actual distance of the point from the mean. All right? Now, your calculator, fortunately for us, we rarely do this by hand anymore. Back in the day when I was taking statistics, walking to school both ways uphill in the snow naked, we had to do all of this by hand. Now, you just plug these numbers into your calculator and it spits them right out. But you do need to know where the formula comes from, where that value comes from. And this is the formula for standard deviation. Copy it down. We'll talk about it more in the future. Q1. This is the first quartile. Okay? This is the first quartile. This value is the median of the lower half. Oh. So that's the median of these red numbers down here. And remember now, the actual median was in here, so I'm going to use this. I do not use the actual median when I calculate the quartiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The middle number will be between 5 and 6. 1, 2, 3, 4. 1, 2, 3, 4. So therefore, once again, my first quartile is going to be 1. By the way, if you're scoring at home, or even if you're alone, the actual standard deviation for this problem, let's see if I've calculated that anywhere. Oh, I haven't calculated it yet. So I'll calculate it for you and give you that value. Q3 is the median of the upper half. Again, same thing. Now we go up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 10 data points. We go to the middle two, 1, 2, 3, 4, 1, 2, 3, 4. Take the average here, 4.5. And again, I'll get questions here in just a moment. So that's the median of the upper half. But for both quartiles, here, make this little note here. Do not use the median when calculating the quartiles. All right, now and we'll do an example in a few minutes with an odd number of data so you can see that. Okay, Q1, Q2. IQR is just the interquartile range. And as I explained earlier, range is just max minus min. So this would be 4.5 minus 1, which would be 3.5. That's the interquartile range. The range itself is the max minus the min. So in this case, 10 minus 1, which would be 9. And then finally, the last thing we add here were the outliers. Now, in the earlier problems that we did, we just sort of looked at the data and said, it looks like an outlier, right? The kid who had 120 beats per minute as a pulse. It looks like an outlier. Is there a way to calculate it exactly to determine whether or not we can use that word? Yes, there is. Here's how we do outliers. On the lower end, we take Q1 minus 1.5 IQR. And on the upper end, we take Q3 plus 1.5 IQR. Now, what does that mean? Well, let me show you. Quartile 1, for our example, was 1. So this would be 1 minus 1.5 times 3.5. So we would just fire that into our calculator. And of course, there are going to be no lower outliers because that's going to be negative. But if I were to do that,
Wait, where are you getting 1.5?
1.5, that's a made up, that's a given. This is part of the definition.
Okay.
So this is negative 4.25. Did the U.S. women's team, national team, ever score less than negative 4.25 goals? No. Let's do the upper outlier, though. Watch this. Now, remember, this is our definition. We'll go to Q3, 4.5, plus 1.5, again, times the IQR, which is 3.5. So here we go. So let's go 4.5 plus 1.5 times 3.5. 9.75. Did the U.S. women's national team ever score more than 9.75 goals? Yes, they did. 10. So 10 would be an outlier. Even though there's a 9 that's kind of close to it, 9 is really close to the cutoff. So 10 is an outlier. So we can actually use outlier as a specific definition. Now, I went through a lot of these definitions quickly here today, but this is exactly what we're doing. All right, so let's go through them one more time. And again, I encourage you to watch the video again and make sure you understand them all. Mean, that's the average. It's the sum divided by the number. Median, that's the middle number. If you have an even number of data, you take the two numbers in the middle, divide them by 2. If you have an odd number of data, you actually have a middle number. So there's your median. Standard deviation. It's a little trickier. Each data point minus the mean squared plus next data point minus the mean squared, et cetera, for every data point. Divide by n minus 1. We'll explain that in chapter 7. And then take the square root. So part of it's just learning and memorizing a formula. Median of the lower half, first quartile, Q1. Median of the lower half. Don't use the actual median, though, when calculating it. Q3, median of the upper half. Don't use the median when calculating it. IQR, difference. Range, max minus min. So the IQR is Q3 minus Q1. The range is the max minus min. And then the outliers, the 1.5 IQR, this is just a formula that statisticians have accepted as an outlier. This is how the statisticians have defined what an outlier is. So that kid's really tall. Is he an outlier? Well, I don't know. Let's take the third quartile, add 1.5 times the IQR, and see if that kid is taller than that number. And so in this case, the lower quartile doesn't make any sense, nor should it, because most of our data is clustered down here. But the upper one, you do have this 10 out here. And that ends up being an outlier. So these are ways we measure center. We're going to do some problems, talk about their relationship as we move forward. Thank you.